This is lecture 13 for Data Science 100 and Data Science 200. The topic is ordinary least squares. So in this lecture, we'll formalize the multiple linear regression model from the end of last lecture, and we're going to do that using linear algebra. So let's see a quick recap of simple linear regression from last lecture. So in the last lecture, we reintroduced the simple linear regression model from data 8. We have y hat, our prediction, is equal to theta naught plus theta 1 times x. So we have two parameters and a single input feature x. We determined the optimal parameters or parameter estimates by minimizing the average squared loss or mean squared error. So we have theta 1, the optimal slope, equal to r, the correlation coefficient, times the slope of y divided by the slope of x. And we have theta naught, or the optimal intercept, equal to the mean of the y's minus theta 1 times the mean of the x's. Now, we extended the idea of the simple linear regression model to include multiple input features. So here we have y hat equals theta naught plus theta 1 times x1 plus theta 2 times x2, all the way up to theta p times xp. So this is a multiple linear regression model with p features x1 through xp. Now, x1 could be the number of assists that a basketball player averaged. x2 could be the number of three-point attempts that that player averaged. We discussed multiple r squared values, but we didn't talk about how to find the actual optimal model parameters for the multiple linear regression. We said, well, we need to minimize the mean squared error, but we didn't actually do that. And that brings me to this lecture, because that's exactly what we're going to do in this lecture. We're going to use ideas from linear algebra to rewrite the model in terms of a vector dot product. We're going to formulate the problem statement using vector norms. We're going to use a geometric derivation to solve the optimal theta. In this case now, theta is going to be a vector. And we're going to explore properties of residuals and understand when a unique solution exists. So there'll be lots of linear algebra. And we have a resources post on Piazza if you need a refresher. And we're going to try and take it slow so that you can follow along.